Hello everyone. So in this video we are going to see the LTCT metering or the whole current three-phase metering, where we have the phases R, Y, B, and we are taking a practical example of say one of the phases due to metering inefficiency or due to metering defective and all. Then if in case one of the phases, either the voltage or the current fail due to the connection issue, due to the weather issue, then in that case you will have to give additional unit to a particular consumer. You cannot compensate, or you cannot apply section 126 or section 135. You have to give additional unit, and this additional unit system allows all over India. And how do we actually calculate? For example, in this particular, say this is a TTB, this is LTCT metering, all right. And say, for example, let me first take the whole current meter. The whole current meter, if in case this particular phase fail, then how much of additional unit will you give, and the calculation of that also I'll let you see later. uh, so this is actually 33.33% of the entire measuring system. This is how you take the weightage. And this is a case of whole current meter, where if one of the phase goes out, then your PT will also go out, and your current will also go out, because they are internally connected. Because this is actually nothing but a 3 watt hour method, a 3 watt meter method in the measurement of power. Like you will see, it is like this, all right. So the connection will be based on this. This is like your R phase, this is S1. Internally inside the meter it will be like this. The potential coil is there inside, to which only two connection will be there. So this particular one, this will be S1 of the meter, S1, and S2 R phase. Okay. And the PT is there inside, where this is a case of whole current. But in the case of LTCT, this will come out separately. That's why you have to give separate voltage. There's will be one more terminal will come, that is S1, S2, and then R will be there outside. I'll show you. It will be like this. It will be like this. It will come out separately like this, all right. So this is the idea actually. So this R phase voltage will come out separately in case of LTCT metering, where we are not using any PT, but we are using only CT in LTCT metering. So this is to understand things actually. So we'll come again to the 3 watt hour method, 3 watt meter method in the measurement of power. Or if time is taken into consideration, then you will get the energy, all right. So the basic idea is that it is a 3 watt meter method. So this will be S1, this will be S1 in the meter connection, this will be S1 of our phase, this S2, this is case of whole current. Then the potential will be the same point only. And then same for the R phase. For Y phase, this will be S1 and this will be S2. And for B phase, this will be S1, this will be S2, and then the neutral is like this. The neutral, we can connect a coil like this, but then normally there is no current in the neutral. But if in case of unbalanced load, there will be current. So this is the load. Okay. So this is our understanding. So now, if this fail, if there is no potential coil, if the PT fail, or the CT fail because of CT open circuit or short circuit at the TTB, then the entire power measured by the blue one, blue one, because this is actually a multiplication of I and V, will be zero. In that case of either PT supply or the current fail, the energy recorded in that particular phase will be zero, and then accordingly you can calculate how much is the additional unit to be added for that particular consumer, all right. So this is actually an LTCT meter, where I have given the connection like this. The PT supply, I have tapped from the phase only, because this is a domestic supply. Because for testing purpose, I have given a single phase supply to this meter, all right. And I have converted to three phase the single phase metering into a three phase metering, where in the R phase I have connected a heater. There is a heater, all right, which is nothing but a 1000 watt heater, and the corresponding current, if you calculate, it will be around 3.8 3.9 ampere, all right. And uh, in the Y and V phase, I have connected a 7 watt bulb, and as a load. and then see, you will see that the since I have you see this is the meter constant, the meter constant, which is 16,000 uh, number of blinks for every unit of active power consumed. All right, now see, right now the frequency of blinking, the number of blinks is very slow, because the PT is missing in our phase where the majority of the load is there. Right now, if I connect this, I mean, even though the current is there, see, because the heater is running now, it is actually heating, but then heating is going on, but then since the PT supply is missing, this is a case of, in a consumer, you will have lots of these issues. Then how to give the power, the meter is actually not recording the power in our phase, even though the power is flowing, so we have to give additional unit. In this particular case, I have given more unit, but then in when you do the additional unit, you will have to give 33%. All right, now let me give a PT to this R phase. You will have to give to this only. Detail of these you will find. If I give the PT supply, then you see it will blink very fast. All right, blink very fast. That means either both the PT and the CT is important to a meter. If in case CT or PT is missing, then you will have to give additional unit. It does mean that just because CT current is there, secondary current is there, and PT is missing, the meter will record the full current. It is not like that. All right, the PT has to be there. Either the PT or the CT current has to be there always. All right, so this is the weightage. You can say that the R phase or B phase or Y phase weightage. Either we have to take either current or the uh, voltage. All right, so this is how we understand about this. I mean, a little bit of technical for understanding this, but overall it's this is how we understand things. All right, so thank you.